Hello, myself Saurabh Noskor, Assistant Professor of Chemistry at Gargi Memorial Institute of Technology. In my previous lecture, I discussed about second part of organic chemistry. Today I will discuss third part of organic chemistry. I will start with Wolff-Kishner reduction. Here, acetone, this type of molecule is called acetone, or you can say propan 2,1, 3 carbons are present, so propan 2,1. So acetone is reacting with hydrogen, this is called hydrogen, to form hydrazone. Now this hydrazone is reacting with either KOH or C2H5OH in presence of ethylene glycol to give a product like propane. See here, when acetone is reacting with hydrogen, H2 and O, they will be removed as H2O. So double bond will be with nitrogen. So we can write C double bond N and H2 like this one. This is called hydrazone. Now when this hydrogen molecule will react with KOH or C2H5OH in presence of ethylene glycol, then nitrogen gas will be removed and this H2 will come to this carbon. So we will get propane and nitrogen gas. Now we will learn another name reaction which is known as Cannizzaro reaction. Aldehyde lacking alpha hydrogen. This is a aldehydic group and this carbon having no alpha carbon, so there will be no alpha hydrogen. So this type of molecule is formaldehyde and this is lacking of alpha hydrogen. Upon treatment with strong base like 50% NaOH or KOH, undergo self-oxidation and reduction. It will oxidize, again it will reduce. This is called self-oxidation and reduction, in which one molecule of aldehyde, say this one, is oxidized to acid. So this is the oxidation process. Now while the other one is reduced to alcohol, so this will be reduced to alcohol. So one molecule will be oxidized and one will be reduced. This type of reaction will be called Cannizzaro reaction. Now phenol on treatment with Br2 in presence of CS2 solvent gives two isomeric monobromophenol X and Y, but phenol on treatment with bromine water gives a white precipitate Z. Identify X, Y and Z. So we have to identify this structure of X, Y and Z. So first we will treat phenol. Phenol means benzene having OH is called phenol. Phenol on treatment with Br2 and CS2, there will be an electrophilic substitution. So here electrophile is Br plus. So Br plus can go either in ortho position or in para position. So one bromide group will go in the ortho position and in another molecule that will go to para position. So we will get a product like this and this. This is called orthobromophenol and this is para-bromo. So para position bromine is present, that's why this is called para-bromophenol. Now we all know para product are always major product and this ortho product are minor product. Now we will treat this one with bromine water. In presence of water, bromine can go in either in two ortho position, another para position. So bromine will go all the three position, that is one ortho position, another ortho position and this one is para position. So name of the molecule will be 2,4,6 tribromophenol and this is a white precipitate. So we identified structure of X, Y and Z. This is X, Y and Z. Now we will see Friedel-Crafts alkylation and Friedel-Crafts acylation. Alkylation means alkyl group should be attached. Alkyl group is R group. Alkyl may be methyl, ethyl, propyl, anything. And there should be acyl group. Acyl group should be attached. Acyl group is when R means alkyl group is connected to a carbonyl group. So R is bonded to CO, then that type of group will be called your acyl group. So see, here benzene is treated with RCl in presence of a Lewis acid. This Lewis acid will take this Cl, so there will be formation of R plus, then R plus will go there. So benzene and R should be there, that type of. Here in step 1, formation of electrophile RCl will react with LCl3. LCl3 will take this Cl, so LCl4 minus and R plus. In the second step, this R plus will substitute this hydrogen and it will take the position of hydrogen. So benzene single bond R will be there. This is Friedel-Crafts alkylation. And Friedel-Crafts acylation, benzene is treated with RCOCl plus Lewis acid. So in the first step, formation of electrophile like alkylation. So LCl3 will take this Cl, so there will be formation of AlCl4 minus and RCO plus. Now this RCO plus will substitute this hydrogen, so we will get a product like this. This is called Friedel-Crafts acylation. Now we will see what is Markovnikov rule and what is anti-Markovnikov rule. With a question, predict the major product of the following reaction and explain their formation. So we will have a unsymmetrical alkene. Why unsymmetrical? Because this carbon having one hydrogen and this carbon having two hydrogen. That's why this type of alkenes are called unsymmetrical alkene. When he was treating with HBr, then see, addition of HBr to an unsymmetrical alkene takes place according to Markovnikov rule. And what Markovnikov says? Markovnikov says that here negative part, here H is positive part and Br is negative part. So negative part of the reagent adds on to that carbon which is having least number of hydrogen. So here negative part will be added to this carbon and positive part will be added to this carbon and double bond will be single bond. So this will be your major product. And when you are attaching this one with this carbon and hydrogen with this carbon, that will be your minor product. Now when this unsymmetrical alkene, and this rule is called Markovnikov rule, this is Markovnikov rule, and when you are treating this unsymmetrical alkene with HBr in presence of peroxide, then there will be anti-Markovnikov rule. Anti-Markovnikov is just opposite of this Markovnikov rule. So addition of HBr to an unsymmetrical alkene in presence of peroxide, this one, and in presence of peroxide takes place according to anti-Markovnikov rule. Here the negative part of the reagent means Br minus add onto that carbon atom of the double bond which is joined to more number of hydrogen atoms. So here negative part will be attached to this carbon and H means positive part will be attached to this carbon and double bond will be single bond. So this will be your major product. And when you are attaching this negative with this carbon and this positive with this carbon, then that will be your minor product. So always remember in Markovnikov rule, when there is no peroxide, there will be Markovnikov rule, and when presence of peroxide is there, then there will be anti-Markovnikov. Markovnikov says that negative part of the reagent will add it to that carbon which having less number of electrons, and anti-Markovnikov is just opposite of this Markovnikov rule. Now we will see mechanism of nitration of benzene. Nitration of benzene means in the benzene there will be addition of nitro group, so there will be formation of nitrobenzene. We will see its mechanism. In the first step there will be formation of electrophile. We are treating benzene with nitric acid and sulfuric acid. This is nitric acid HNO3 and this is your sulfuric acid. So they will react to form a electrophile like this. NO2 plus is your electrophile. Now there in the second step there will be formation of transition state. So benzene now will react to this electrophile to form a sigma complex like this. This double bond is making a bond with NO2 and one hydrogen was present there. So this double bond is breaking, that's why here we should give a positive charge. Now in the last step there will be regain of aromaticity. So this hydrogen will go out and this bond will come here to neutralize this plus charge. So there will be formation of nitrobenzene. And this, so in the nitration of benzene, 3 steps involved: step 1, steps 2 and steps 3. Now the last question is, we have to synthesize paracetamol. See, this is your 4-aminophenol. Actually this is your benzene and OH means phenol, and in the fourth position there is one amino group, so we can say 4 amino, and this is phenol, and this is your acetic anhydride CH3 C double bond O O CO CH3. Here nitrogen having lone pair will attack this carbon, so this bond will open up as minus O minus, then this O minus will back as double bond, and this whole bond will be clipped, this one will be clipped out. So there will be attaching of NHCOCH3. This should be attached with this one, so NHCOCH3, and this whole is going out, so CH3 C double bond O, and one H from here will go to stabilize this one. So this is the structure of paracetamol. So in this way you can prepare or synthesize paracetamol. In my next class I will continue organic chemistry. Thank you.